Welcome back to statistics. We're going to do our last required activity for the year. We're going to talk about correlation and regression. And the main reason we want to do correlation and regression is if we can find a linear pattern, we can then use that pattern to make predictions. So a little bit of terminology before we get started here on today's activity. We have two variables, two quantitative variables when we're doing the correlation and regression. And so we call them X and Y. The Y data is what we put into list 2 and is the dependent variable, sometimes referred to as the response variable. And it's the variable that depends on or responds to the values in the X variable, which we typically put in list 1. Okay, so since it is not the dependent variable in list 1, it must be the independent variable, sometimes referred to as the explanatory variable or predictor variable. Okay. Let's go back to our example from last time about the number of inhabitants and the number of crimes in sampling of counties in Utah. Okay. It makes sense that the number of crimes would depend on the people, a lot more sense than the number of people measured in thousands would to depend on time. So we're going to put the number of people as X in list 1 and the number of crimes as Y in list 2. Therefore, our independent variable is the number of people in the county, measured in thousands, of course. And the dependent variable, what responds to that, is the number of crimes committed in the county. Okay. So in our last activity, we took this data and we ran a hypothesis test on it and found out that yes, there was linear correlation. And so let's go ahead and remember the regression equation. So if we go to stats, calculate, and then we use option number 8, ln reg A plus BX, and my data is in list 1 and list 2. Okay, so the X data is in list 1, Y data was in list 2. It will come back up and tell me that Y equals A plus BX, where A is negative 72.87 and B is 25.82. And last time we talked about R and R squared and how to interpret those guys. But let's write those guys down here. So Y equals negative 72.87 plus 25.82 times X. Okay. And as mentioned, the primary purpose of regression equations is to make predictions. So let's go back to our graph from last time, our scatter plot. We saw that it looked like a line here. Let's go ahead and get a little help from the calculator. And so let's go to second Y equals to get to the stat plots menu. Currently all my stat plots are off, so I want to turn one and only one of them on, and I want to make it look like a scatter plot where my X data is in list 1 and the Y data is in list 2. And use either one of the first two options. It's too easy to miss a single pixel. And then I will quit out and then go to zoom. And one of the options is zoom stat. So it'll zoom to the statistics. And that looks a lot like the graph I made by hand last time. But now we have an added bonus. We can put in the equation that models or describes our data. So negative 72.87 plus 25.82 times X. And to get the X variable, we use this key right there. Now if I push graph, it will graph that equation on the scatter plot, and so we can see that yeah, that line is a really good fit, and that's why our R and R squared values were so high. So let's go ahead and maybe kind of try to copy this down onto our other graph so we can reference him. So the line looked to be just above these 3 points and below these 2 points. So let me get a straight edge here and try to draw him in about like he looks. All right, so that would be our predicting line. And so we're going to use the number of people in the county and this line to predict how many crimes there will be. So for example, Millard County is one of the counties in Snow College's Surface District, one of them near San Pete County, and we could take and predict the number of crimes in Millard County for that year. Now, Millard County is small, and there's 12.6 thousand people, and remember that the number of people was measured in thousands, so we'll need to leave this as 12.6, and we're going to put that in for the X value, because remember, X was the number of people in the county, and Y was the number of crimes. So if we go to our calculator and do negative 72.87 plus 25.82 times the X value, which was 12.6 because it was 12.6 thousand people, we would get a prediction of 252.46. So I'm going to let you round either way on this one. So 252 or 253 crimes is what we would predict. So what happened there? We went to our graph and we went to 12.6 thousand people. We came up to where we hit the predicting line, the regression line, and came across, and that number would be right close to 252 or 253 crimes. Okay, so we predict that they will have about 252 or 253 crimes that year. As it turns out, I was able to get the data from Millard County, and there were 275 crimes in Millard County for that particular year. And how does our prediction compare to the actual predicted value, the actual value? That's right, it's pretty close, not exact. So pretty close, but not exact. Okay, all right, let's go to our next page. Let's pick another county in Utah. How about Salt Lake County, which has over 1 million people? So if we remember our units, okay, we're measuring X in thousands of people. So there were 1 million or 1,091.7 thousand people in Salt Lake County. How many would our model predict for the number of violent crimes, the number of crimes in Salt Lake County that year? I'm going to pause and let you figure that one out, and we'll come back together here in a second. Okay, we're back. I used my calculator to predict that Salt Lake County would have about 28,115 crimes. I actually researched the data, and for that year there were 49,562, these were just crimes, in Salt Lake County that year. So how did our number compare? Well, this is a little over half of that, so it's not a very good prediction. Okay, only about half of the actual value. Okay, so this brings up an important question. How come it worked well, or quite well? We were within about 10% on the Millard County, where we were way off on Salt Lake County. Well, there's some important guidelines here. When we did our random sample, notice that our random sample only had smallish counties. So Tooele County was the largest with about 60,000 people in it. Okay. And since that's the largest, if we were to try to draw Salt Lake County on this picture, it would be way, way, way over to the right. It wouldn't even fit on this graph. So that brings up some important guidelines. Okay, so the first one is only use the regression equation to make predictions if your scatter plot looks like it's going to fit the data reasonably well. And basically, the rule of thumb is to only use the regression equation if you can do a hypothesis test and reject H0. Okay. Now, we mentioned this earlier, since the number of people in Salt Lake County was greater than all of the sampled counties combined, Salt Lake County probably doesn't fit in this kind of a sample. This is medium and small size counties where Salt Lake County has a large population. So only use your prediction on where he applies. So you've got to what we call stay within the scope of the sample data. So if your sample data only includes small and medium counties, don't try to use that to make predictions for large counties. And finally, if there is no correlation, then don't use the regression equation to make any predictions. Okay, your single best guess if there's no correlation is just to find y bar as your best predictor for any value of x.